Welcome back, everybody. This is yet another video about promises, and this one follows up on a lot of what I've explained so far, as well as a discussion I had in this video. So, fun function with MPJ. I often reference him because I really enjoy his videos, and there was a lot of questions in the comments about how to deal with multiple promise rejections and dealing with and handling promise errors or continuations in different situations. And it got to be quite the thread. And there were a lot of different opinions. And if I understand the question properly, then I think this video will give a bit more context to the answers and responses I gave in that thread. So let's get to it. First things first, there's a couple different situations that we could be trying to solve here. And so the first one, which is the one I'll start with, as you usually do if it's first, is where you have multiple tasks, processes, whatever you need to have completed, and then each task relies on the successful completion of the previous one. So task 3, in this case, should not run before task 2 successfully completes, which should not be executed until task 1 successfully completes. Now, since we're dealing with promises deal with asynchronous code, I have decided to make each promise, the resolved value in each promise wrapped in a set timeout with the promises completing in reverse order were they to simply race. So task 3 is the fastest, task 2 is in the middle, and task 1 is the slowest. That way we can be very clear when we are allowing them to just race and when we are saying, no, task 1 has to be completed before task 2. So the other situation, which I'll get to second, is where the tasks are independent and we can just allow them to run and they will complete or fail appropriately and we will handle them appropriately. So one of the responses I got basically seemed to imply that this was the best solution, and it may not have been that that's really what he meant. It's not like you get a lot of time to explain yourself in YouTube comments, but the point is that if you execute a function that returns a promise, you can call .then on it. And so if the task is successful, we can then just console log the resolved value, which in this case would just be task 1 completed. .then for task 2 would be task 2 completed. Then for task 3 would be task 3 completed. And then if all the thens have successfully completed, we will execute the all done function, which just console logs all tasks completed. Now that's important. If all tasks were successfully completed, then will be called. And if any fail, so if any of them throw an error, then that will bubble up all the way to the end of the promise chain where we will say error, and then the error, which we'd write something like reject task 3 failed. All right, so if we run this, oops. Because promises deal with asynchronous code, they say once something's done, we say what to do next. And even though task 1 is the slowest, task 1 completes, and then we execute task 2. And then task 2 completes, and we execute task 3. And because they were all successful, all tasks completed gets called because all done is the .then. Now, if we go up here to task 2, and we, instead of resolving, we reject it. And instead of saying completed, we say failed. Now, when we reach task 2, we'll say then task 2. It will, instead of calling then, it will call .catch. It'll pass the error in, which will get thrown. That will return a rejected promise, which means it will go to the next catch, which will then throw the error, which will then go to the next catch, which will then console log the error. And so it just weaves its way all the way up the promise chain. And so we'll see task 1 gets completed, task 2 fails, and nothing else runs. And we don't want anything else to run because task 3 is dependent on the successful completion of task 2. And so since it failed, there's no point in running it. Now, this, like I said, works just fine. And I think that was the point of the thread. Like, hey, let's not overcomplicate things. This works just fine. But my opinion is that this is a lot of repetitive code. And if we're handling all of our tasks in the exact same way, why write it so many times? So my suggestion is to use function composition. And if you're unfamiliar with the compose async function, check out my asynchronous function composition video. It explains it thoroughly. And what we will do is create the exact same code up above, except it will be in these 3 lines of code down here. What this means is we will simply create a list of all the tasks. Task 1, task 2, task 3. These are just functions that return a promise immediately and resolve in the reverse order as far as time goes. So the same code as above. Well, what we can do is the same as what we've done down here, which is wrap each function that returns a promise in a new function, append the .then with the console log and the .catch with the error throw error. So that I'm including this code because it will produce the exact same output as this code in case the map is confusing you. So if this is clearer, cool, that's all that this map is doing. But let's actually look at the map. So it's saying for each task, I want you to return a new function. Inside the body of that function, we'll execute the task, which means that we're going to return a promise. And we can call .then on a successful promise and .catch on a rejected promise. And this is the exact same code that we used above. Now, by composing all those together, we now have a list of functions that when executed will immediately execute the promise. And we have to wrap it in a function because we can't execute the promise, or we can't execute the function, the task, as we map over to transform it. We need to wait until down here to execute it. So that's why we wrap it in an outer function, so that when we compose them all together, the promises will not be executed until we actually execute the composed function. And if this looks like a familiar idea to you, you've probably watched the monads video that I made recently, because this is an applicative functor. So now I will go back up to the top here and just remove the rejection so that we can see a success first. Completed. Task 1 completes, task 2 completes, task 3 completes, and we get all tasks completed. And if I reject at task 2, task 1 completes, and then everything ends because task 2 failed, which bubbles all the way up to the end of the promise chain, and no other tasks are run. Now, the reason why I prefer the compose code over this explicit chaining is that now we could have as many tasks as we want, and all we have to do in order to change the execution of this code is add another task to the list. So if they can all be handled the same way, we can just keep adding them. We could have task 4, 5, 6, 700. It doesn't matter. Our call site still is just these 3 lines of code. And we know by looking at it that, okay, if they all are successful, we'll call .then, which will say that they all completed successfully. And if any fail, we'll call .catch. That's the essence of why promises are so perfect for solving this asynchronous function composition problem, due to the fact that they're monadic. And I really think that if you're using promises without function composition, you are limiting yourself as far as the code that you can write. So anyway, I think this is more simple, more scalable, easier to recognize, but that's my opinion. Now, this is the code that's much more interesting to me, which is where you have tasks that are independent. So we don't care how long task 1 takes to run, or if it fails. Task 2 is going to do its own thing, and task 3 is going to do its own thing. All we have to say is, hey, you guys all execute, and then we'll handle the rejections individually. So remember, this is just to show you what all tasks is, in case you've forgotten from above. All tasks is just our list of every task. And here we will map over them, and for each task, we'll return that task executed. So that's the big difference here. We are not wrapping it in a new function to be executed later. We're immediately, as we map over it, executing each function. We'll then append the .then for a successful completion, or .catch for the unsuccessful completion. And this is also slightly different. Because we don't care if any of them fail as far as the other ones completing, we just want to run them all, we'll console log any errors that we get and then throw a general error that says one or more tasks failed. If they all are successful, promise.all will resolve into a single promise that is resolved. And then we'll call .then. And if any of them fail, .catch will be called, .then will not be called, and .then is just running the function all done that says that they were all successful, which would be a lie if all of them completed, but one or more of them was rejected. So we want to know that one or more of the tasks failed. Okay, so if I run this with all successful functions, actually I think I must have left it failed, yes. So apparently we're gonna look at the failed code first. And since task 3, remember, is the fastest, it completes first. Task 2 fails, and so we see a log of task 2 failed, and then the general log of one or more tasks failed, but task 1 still gets to run because they're independent and we wanted them to still run. So what's actually happening? As we map over all tasks, each task is synchronously executed, but they're not, because they're asynchronously completed, the throw cannot interrupt this map. Because JavaScript is single-threaded, .map will be running over all of the tasks in our list and executing them all no matter what. So even if it took 10 seconds for all of our tasks to be executed, the throw that returned after half a second is not going to interrupt those other tasks being run. And that's because it's single-threaded. The throw needs to wait because it's asynchronous. It needs to wait until all the tasks have at least started. And then once there's a space for it to enter back into our program and to execute something, then the throw will be executed, which means that we will then see that one of the tasks failed, but it doesn't prevent the other tasks from running. If you have independent tasks, I think that this is just quite simply the easiest, clearest way to handle them. You get independent error logging. This could instead be something like notify user or log to admin, error handling, whatever. But then you also get your general summary so that if everything was successful, you get a log, everything was successful, no need to worry. But if one or more tasks failed, you get that global general failure. So if I hop back up to the top here and I resolve, actually let's just show you. So if I do here, actually since number 3 is the fastest, let's reject that first. Reject, failed. Now if I run this, get task 3 failed, one or more of the tasks failed, then task 2 proceeded to fail, but task 1 completed. Because they're independent, that does not matter. We will be happy that task 1 at least completed, but we can check our logs and see that the other 2 failed. And this would probably be where we would put our general alert. So let me just hop back to the bottom here. The way that I've written it in my program is or my applications in general, is that I actually have an alerting system so that if one of these global failures were to occur, then I would get an alert with that. So it would be something like, I'll just call it alerts me, right? So alert me, this might send me an email that says error, this error occurred. And then I know that one or more of my tasks failed, I could check the logs. But this might just be something like output to the UI. Right, so output to UI. So this would basically be for the user to recognize the issue in real time, whereas the global error would notify me whenever I get around to seeing it. Hopefully that makes sense. Hopefully this answers the questions, because a lot of people were asking about these more complex situations where you have multiple promise failures and you want to handle it in multiple places. The big key here is that we're returning something in all of these situations so that it can continue to pass up the promise chain. You have a global failure that you can catch. You also have a local failure that you can catch and handle individually. Hope you enjoyed the video. If you did, like the video, comment if you want to see more anything similar to this. If you have some follow-up questions, let me know, and I will see you in the next video. Bye, guys.